Welcome to qnawire.
We're told that a pilot is flying a plane at a direction 55 degrees above the horizontal and a velocity of 75 meters per second. So the velocity in the y and the x directions then are 75 times the sine of 55 and then 75 times the cosine of 55. The plane is at a height of delta y of 150 meters. And of course, the acceleration in the y direction is going to just be minus g minus gravity, which is 9.8 meters per second. We want to figure out how far the bale of hay is going to go if he releases the hay from the plane at this height, traveling at this distance. So first we need to figure out the amount of time it's going to take for it to hit the ground, which we can use the equation delta y is equal to v naught in the y direction, which we're just going to call v of y here, minus 1/2, the minus sign comes from gravity, times the acceleration, which is gravity. Oh, I actually forgot the t here. Sorry about that. This is velocity times time, of course, minus 1/2 gravity times time squared. So we can rearrange this equation, and it's going to be 1/2 times gravity times time squared minus velocity in the y direction times time plus delta y is all equal to 0. So the minus sign switch around just came from the fact that you can multiply this whole equation by -1. 0 times -1 is just 0 still. So the right side of the equation remains 0, and the sign switches on the left side of the equation. So we can use the quadratic formula here to find t. T is going to be equal to velocity in the y direction, and then plus or minus, but we want the positive time because we don't care about a negative time, the square root of the velocity in the y direction squared minus 4 times 1/2 g, which is 2 times gravity multiplied by delta y. And this is all divided by 2 times 1/2 gravity, which is just gravity. Plugging those values into this equation, we find that time is equal to 9.2 seconds. So using this time that we just found, we can find the distance it's going to travel in that time, delta x, since it's just equal to the velocity in the x direction, which we showed at the beginning, multiplied by that time we just found. So we find that this is equal to 396 meters. We can box that in as the solution to our question.